Today we're going to try and help a student who's asked for help with present value. Now there wasn't any details that were given to me, so today I'm just going to do as many different types of questions to do with present value, and hopefully one of those lands. So just to start off with, what is present value? Well, present value is basically how much money you need to have today, presently, to achieve a certain amount of money later on under a certain amount of interest rates. So let me give you an example. So when I was younger, probably around your age, when I was about 17 or 18, I was thinking I want to have $1 million in my bank account by the time I'm 30. I want to be a millionaire by 30. Who shares that dream with me? So how much do you need to have right now, put in your bank account, and then not touch it until you're 30 and just let the interest accrue and have $1 million by the time you're 30? So keep this question in mind. We're going to do some other questions, and then at the end I will come back to this question, and hopefully by the end you'd be able to work it out for yourself. So let this be a bonus question for the end. Now let's try this question here. Question 7. Louise wants to retire in 5 years' time and buy a small nursery. She estimates she will need $35,000 in 5 years. How much must she invest today at 9% per annum, compounding monthly? That's important. So that she will have $35,000 in 5 years. Alright, so present value is equal to future value over 1 plus the interest rate to the power of the amount of times that interest rate is going to apply. So the future value is the $35,000 because Louise in the future wants that amount of money. The interest rate is going to be 0.09, which is 9%, divided by 12 because it's compounded monthly. Alright, let's find out how much that is. That is 0.0075. So that will be the interest rate monthly. The n, the number of times the interest rate is going to apply, is going to be 5 times 12 because it's 5 years and there are 12 months in every year. And the interest rate is going to apply each month. So that will be 60 times the interest rate is going to apply. Therefore, the present value is going to be 35,000 over 1 plus 0.0075 to the power of 60. So 2, 2, 3, 5, 4, 4, 9. She needs $22,354.49 right now to put in her bank account, not touch it for the next 5 years at 9% per annum compounding monthly. And then by the end of that 5 years, she's going to have $35,000 in her account. Make sense? I hope so. Now hopefully knowing this one, you should be able to work out if you're going to be a millionaire by the time you're 30. Let's move on to another type of present value question. This question asks, what lump sum does... So lump sum is just a whole amount, right? Not broken up, just a big lot of amount. What lump sum does Terry need to invest today at 8% per annum for 16 years to give the same final amount as he would achieve from periodic contributions of $2,500 per year at 8% per annum for 16 years, both investments compounding annually. The question is asking, how much does Terry need to invest today, right now, for 16 years at 8% per annum, compounded annually, for it to be the same amount as if he put in $2,500 a year at the same rate, same amount of time, to achieve the same amount in the future. So this would be present value. Okay? This is where another formula comes in, and it is present value is equal to payment amount. So there's $2,005 a year, which is the big capital M, outside of 1 plus r to n minus 1 all over r outside of 1 plus r to the n. Following this, we could say that the m is 2,500. Okay, 1 plus the rate, which is 0.08, to the power of n, which is 16. Let's put that 1 over there. Minus 1 all over 0.08 outside of 1 plus 0.08 to the power of 16. Okay, now we just have to very carefully put this into the calculator. You would need 22,000 12842. 12842. So Terry needs to put in $22,128.42 today to achieve the same amount in 16 years at 8% per annum compounding annually, as if he would put $2,500 a year for the same amount of time at the same amount of interest rate. Then he would have the same future value. Now that you know this formula right here, you can now work out, instead of having a large amount of money right now to get your million, you can see how much you need to deposit every month or every year to achieve that $1 million at 30. So we'll see what everyone comes up with at the end. Let's move on to another type of question. We have here question 8. When he retired, Kevin invested $50,000 at 8% per annum for 20 years. A. Kevin plans to make equal annual withdrawals from this account for the next 20 years. After 20 years, there'll be no money left in the account. How much can he withdraw each year? That is, find M. Remember our formula. So we want to find out what our annual withdrawal is. The number of times that the interest applies will be 20. I believe it's annually. Doesn't say otherwise, so I'm going to assume it's annually. Our interest rate is 0.08, and our present value is 50,000. Okay, let's figure this out. 50,000. M is what we're trying to find. 1 plus R would be 1.08 to the power of 20 minus 1 is 0.08. 1.08 to the power of 20. We'll just find out what that is first. Now to find M, we just do 50,000 over 9.818 dot dot dot, which equals, I'm going to do 50,000 divided by answer equals 509261. 509261. Therefore, if Kevin withdraws $5,092.61 every year, his account will be zero after that 20 years. And then B, how much interest will the account earn over the 20 years? We just need to, so over 20 years, the amount, total amount, I should have said. Oops. Total amount is going to equal $5,092.61 times 20, which is 101,000. What was it? 85221. 85221. And he invested 50,000. Therefore, the interest the interest earned will equal that $101,852.21 minus his 50,000 that he put in, which is going to be 185,221. So he earned more interest than what he put in. He put in $50,000, and in 20 years, he actually earned almost 52,000 more just from interest. That's pretty good. I hope I haven't lost anyone here. If you have more questions, you can always comment, and I can always make more videos. But for this video, I just want to cover as many different types of questions as I can. All right, moving on to a borrowing type of question. It says, to pay her holiday, Belinda borrowed $3,000 from the credit union at 6% per annum, and she arranged for the equal quarterly repayment to be automatically deducted from her pay for the next 3 years. A. Calculate the size of her regular quarterly loan repayment. B. How much will Belinda repay altogether? And C. How much interest will she have paid over this loan? Let's work out a few things. So we know R is going to be 0.06 divided by 4 because the repayments are made quarterly. Since the repayments are being paid off quarterly, I'm going to assume the interest is also being compounded quarterly because I have no other information to go off. Now what will that be? 6 divided by 4. 0.015. What else do we know? The number of times that the interest is applied will be 3 times 4. That's 12 times. So there's 4 quarters in each year. So therefore there are 12 quarters in 3 years. And then she borrowed $3,000. All right. And we are trying to find the loan repayment. So M. Let's get out the equation again. $3,000. We're looking for M. This is 1.015 to 12 minus 1. 0.015. 1.015 to 12. So M is going to be 3,000 over 10.907 dot dot dot. And so equals 27504. 275. Therefore, Belinda makes a quarterly loan repayment of $275.04 for 3 years. B. How much will Belinda repay altogether? Altogether, total, she's going to pay $275.04 multiplied by 12 times 12, 330048. Then C, how much interest will she be paying over the loan? Interest would simply be how much she paid in total minus how much her holiday was supposed to be, which is $3,000. So that means she paid an interest of $300.48. All right. Now you know that the present value equations can be applied to a savings type of problem and also a debt type of problem. Sometimes you're going to get a table like this for a present value question. Let's have a closer look at it to see if we can figure out this table. The title says present value when a regular payment of $1 is made with a period amount. So period is just the number of times that the interest is applied. And then the interest up here. So we have 1% up to 4%. And then there's a whole bunch of decimal numbers in the middle. What do they mean? What are these? These numbers are what you would multiply to that $1 of regular payment to find out the present value needed. So to find out what the lump sum of money that is needed right now to achieve the same amount of future value as if you put $1 repayment at a certain amount of period of time and a certain amount of interest rate. So let's do this question and hopefully that will make sense to you. The question asks, George makes repayments of $400 at the end of each month into his investment account for 8 months. He receives an interest rate of 18% per annum compounded monthly. By referring to the table above, calculate the present value of his investment. He is making $400 repayment a month for 8 months. That means N is going to be 8. The interest rate is 18% per annum, 0.18, but we have to divide it by 12 because it's each month. 0.015. Where is that in the, this is 1.5%. Okay, where is that in this table? So we have 1.5%. We have a period of 8. So we are actually looking at this factor here. This number is 7.486. That means we can work out how much he needs to have right now instead of this monthly payment thing. So the present value is going to be 400 times 7.486. And the reason why we do that is because this table is for $1. You times $1 by 7.486. And since he's making a $400 each month repayment, we do 400 times 7.486. 400 times 7.486. So he needs 29944. 299.40. So he needs almost $3,000 in his account right now to achieve the same result in 8 months with 18% per annum compounded monthly as he would if he put in $400 each month for 8 months for the same amount of interest. All right. Question B asks, what does this amount in question A represent? So now you know. People who are good at English will be better at this than I am. So as long as you explain that in both cases, whether he puts in $400 a month or put in $2,994.40 in his account right now and not touch it, they will arrive at the same future value. Good? Example 2. Jane has $12,000 sitting in her bank account. She receives an interest rate of 4% per annum, compounded quarterly. Her sister Karen has no money in her bank account and would like to have the same amount of money as Jane. These sisters are very competitive. What quarterly repayment will Karen need to make so that she has the same amount of money as Jane by the end of 2 years? Assuming Jane makes no repayment. Let's see what we know so far. We know that Jane has $12,000. Oops. Jane has $12,000 sitting in her bank account, having an interest rate of 4% per annum compounded quarterly. So that's 4% divided by 4. So that's 1% per quarter. Her sister Karen has no money in her bank and wants the same amount in 2 years. All right, so how many quarters is that? That's 8 quarters. So let's have a look at our table. This time we're looking at 1% and we're still looking at the 8. So we are looking at 7.652. The question is, how much does she need to put away every quarter? 7.652 to have $12,000. So instead of finding out how much we need to have in the account right now, like the last question, this time we're looking at how much repayment on a continuous basis, so this is a quarterly basis, to have the same amount as if we have a lump sum amount right now. So it's very simple. You just divide 7.652 on both sides, and you're going to get M is equal to 12,000 over 7.652, which is $1,568.22. $68.22. Therefore, Karen will need to put away $1,568.22 every quarter for the next 2 years to have the same amount of money that Jane would have in her account after 2 years of accruing interest. I hope that made sense. If not, again, just ask me to make another video and I'll go deeper into it. But for now, I think we want to go back to our bonus questions, right? The question was, if you're going to be a millionaire by the time you're 30 and you are currently 18, how much money do you need to have it right now? What is the present value to have a future value of $1 million? Let's work out a few things. There is one more thing we need to figure out, which is the interest rate. And I think the current interest rate for a savings account is roughly around 3%. So I'm just going to go with a conservative amount of 3%. And we're just going to assume it compounds. In real life, bank accounts compound daily. But to make this easier on ourselves, actually, let's go ahead. Let's try to do it daily. So compound, this is 3% per annum, and compounds daily. We know that the interest rate is 0.0 3 divided by 365 days so that we can accrue this on a daily basis. And how many times does this interest rate get applied between the time you're 18 till you're 30? Well, it is 12 years to get from 18 to 30. And within that 12 years, there are 365 days to accrue interest. Therefore, the interest is going to accrue 4,380 times. All right. Now we can work out how much we need in our bank account right now. So PV is equal to future value over 1 plus the interest to the power of n. Future value, we want $1 million. And 1 plus the interest, so 1 plus 0.03 over 365 to the power of 4,380. Isn't this exciting? Or I'm about to crush a lot of dreams. I'm so sorry, but let's be realistic. Ready? You need to have, at our current interest rate, almost $700,000 in your account right now. 68665. Oops. You need $697,686.65 in your account today at the current interest rate of about 3% per annum, compounded daily, to achieve your dream of being a millionaire by the time you are 30. How are people feeling right now? Okay, so we might not all have $700,000 in our account right now. If I have $700,000, I'd be super happy. I'm not even going to dream about the $1 million anymore. I'll just take the 700,000, thanks. So we might not all have 700,000 in our account right now. The next question is, how much do we need to put away on a monthly basis, let's say, to achieve our $1 million status by the time we're 30? Let's try and work that out. Since we've worked out the interest rate on a daily basis, I'm just going to work out what we need to put away every day from now until we're 30 to get the $1 million. All right? If we can work out how much to put away every day, we can work out how much to put away every week, every month, every year, etc. So the formula is, we want $1 million. Future Astrid here. I just found a mistake in my working out. The present value should be the same present value as what we found previously. So that should be the $697,686.65, not the $1 million I thought it was going to be. So just keep that in mind. 4,380 minus 1 all over the interest. I can write the interest as a fraction, as a decimal, but for now, I prefer fractions anyway, so I'm going to keep it that way. You can do it however you please. 365 to the power of 4380. All right, let's see what that is. It's going to equal m at 3678145 ... I think I got that right. 145 ... Yep. Okay, now we go m is equal to 1 million over 3678.145 ... That's going to equal we need to put away $271.88 every day at an interest rate of 3% per annum for 12 years to get $1 million by the time you're 30. So $271.88 a day. So by the time you're all millionaires at 30, don't forget your friend over here who helped you get there, okay? Until next time, bye!